Let's take a look at the Tellegen's theorem. You are given a circuit something like this. We have element 1 and its polarity is a positive at the top, negative at the bottom. Now you are given the current I equals to 5 amp in that direction. Now you need to identify the polarity of this voltage source. Is it plus at the top and minus at the bottom, or minus at the top, plus at the bottom? We have one more information, and E1 has the power of positive 20 watts. Then the current going into this terminal, positive terminal, that's why power is 20 watts, and then go here, it's gonna go into lower terminal. Based on the Tellegen's theorem, we should have negative 20 watts in here, so that we have the sum of all the power equals to 0. Positive 20 minus 20, that is 0. In order to get minus 20 in here, then it should be this pair. Right? So if you redraw the circuit, you can have plus minus E1, and this is plus minus, and this is negative 20. If you want to calculate the voltage in here, we know P equals to VI, and we know P is 20. We have a V, I is 5, so V equals 20 over 5, which is 4 volts. So this is 4 volts. As you can see, we don't write this as a negative 4 volts. Power can be calculated multiplying V times I, and you need to write positive or negative depends on the polarity of the voltage source. Now, if we look at this circuit, we have node 1 at the top and the node 2 at the bottom. That means this 4 volts and E1, the element of 1, they are in parallel. Again, how do you know it's a parallel? Parallel, we said share 2 nodes, right? Top and bottom. And this 4 volts and E1 also in series. How do you know in series? They do share the same current because there's only one loop, they do share the current. So go back to the parallel. So these two are the parallel. Therefore, the voltage of the element 1 should be 4 as well. That makes sense because we know current I equals to 5 amp. So P equals to V times I, which is positive 20 watts. The circuit is given something like this. Now, we need to find I sub 0 using Tellegen's theorem. So let's calculate all the powers for each element. Starting at the top, power at 6 volts. That is P equals to VI, right? Voltage is a 6 volt. Current, that is the independent current source. And the current going into this direction, and it is Ix, and it is 2 amp. Therefore, this current getting into negative terminal, right? The current going in that direction. Therefore, P equals to 6 times negative 2, which is negative 12 watts. Power E1, we have I sub 0 and getting into 6 volts. So we need to write 6 I sub 0. Power element of 2, that is negative 12 times 9. Therefore, it's going to be negative 108 watts. And then power for E3, we have 3 amp going from go up and entering the negative terminal. So negative 10 times 3, that is negative 30. Now, let's find the power for 8I of x. P of 8I of x equals, the voltage is 8I of x. That's the value of voltage we call the dependent voltage source, and 8 times I of x times the current, which is, we have a 9 going into here, and then we have a 2 coming into this node. Therefore, we are going to have 11 amps going downward. And what is I of x? We said is a 2 amp. So we have 8 times 2, which is 16 times 11, and that is 176. Finally, we need to calculate the power in 4 volts in the middle. Now we need to find the I. We have a 11 amps right here. That is going around 11 and then getting into this node. And then we have leaving 3 amp. Therefore, we should have 8 amp going upward. Therefore, negative 4 times 8, which is negative 32. Now, the Tellegen's theorem says sum of power equals to 0. We have a 6i sub 0. And if we combine these two first, it's going to be negative 120. And then these two, negative 62 plus 176 should be equal to 0. Now we have a 6i sub 0. And these two, negative 182. Then negative 182 plus 176, that is negative 6. Therefore, I sub 0 equals to 1 amp.